Hi folks, so today what we're going to be learning about is the area underneath conics, okay? And specifically the area in conics we're actually going to be focusing on is the area on an ellipse, okay? First of all, an ellipse, guys, is kind of like what looks like a kind of an egg-like shape, okay? Or an oval-like shape where basically you have a circle and it's like you pull the circle and you elongated it, okay? And what we're going to be learning about is where an ellipse actually comes from. So if we look here on the SolidWorks model, we can see here we have a cone, okay, and it's an upright cone, okay, where it's obviously the base of the cone is a circle, and when we look straight at the cone we know that we see a triangle, and when we look at the cone from the top view we're going to see a circle, okay. And obviously then, and I'll just go into my 3D view here, we have a cone here, and obviously we can see that the vertical plane behind it and then the horizontal plane underneath it. So what we're actually going to be learning about is how an ellipse is created. So I'm just going to go back to my right view there and going to take you in here. And an ellipse is created when a cone has been sliced at an angle. So what I'm going to do is I'm going to put in a little cutting plane here, a section view, okay? And what I'm actually going to do is I'm going to rotate that section view, and you can see there it's kind of taking a little bit of the cone away, but I'll pull it back off. So on that section view there, okay, I've basically got this kind of green line here which is at an angle, okay, and I can change that angle to suit myself, it doesn't matter, okay, but what's important to note is that the angle of the green line is different to the angle of the cone, okay. So now what I'm going to do is I'm going to bring that cutting line, it's like I'm taking a slice and I'm slicing the cone away from the top. So you can see here it's starting to disappear. And as I cut that away and I go further and further down, obviously the cut is getting larger and larger. But if I go to the 3D view now, what you'll actually notice is the shape that is made by that kind of cutting plane, we've kind of got this exposed area here, this cut surface, okay? That cut surface there, the shape that it actually generates is what's known as an ellipse, okay? So you can see here, if I bring the cutting plane away, the ellipse gets smaller, and if I bring it further down, the ellipse is going to get larger, okay. So that often depends then obviously on the size of the ellipse that we want to create, but essentially an ellipse is when you cut a cone at an angle, okay, the angle cannot be parallel to the edge of the cone. It has to just be an angle that is not parallel to the edge of the cone, okay, and that's where we get the ellipse from. So as you can see there, the ellipse is generated, and it can be a larger one or a smaller one, okay, and obviously it grows larger the further we travel down along the cone, okay. So that's the ellipse shape we have there. Right folks, so what we're going to do in this video is we're going to learn how to construct an ellipse using the Trammel method, okay. So in comparison to the other video which we have previously done where we constructed an ellipse using the auxiliary circles method, this one is just a little bit different. It's probably less commonly used than the auxiliary circles method, but just as effective, okay. So once again guys, you can see here I've set up my axes. I've got a major axis here, okay, that is 160 millimeters long, and I have a minor axis which is running perpendicular to that, that is 80 millimeters long. So therefore, the major axis being 160, that means the semi-major axis is 80, which is half of the major axis. So the semi-major axis is 80, the semi-minor axis is 40. So essentially 160's diameter, half of it is 80, minor axis diameter 80, half of it is 40. So the method for using a Trammel method, okay, what you're going to actually need is to cut yourself a strip of paper. Okay, doesn't matter, kind of just make sure that the paper is greater than half of the major axis, and that's the main thing, okay. So you can do that, obviously just use maybe your set squares to cut a scrap piece of paper or so forth, okay. And what we're going to use is this paper to essentially help us to construct an ellipse, okay. So the method for it is, first of all, what we have to note is that at either ends of our major axis and minor axis, they are points on the ellipse, okay. So this point here, which is at the end of the major axis, and this one here, that is another point on the major axis, and this point here, or sorry, on the ellipse, and this point here and this point here are also points on the ellipse, which are at either end of the minor axis. So the method for actually using the Trammel method for constructing an ellipse is this. What you do is you take your scrap piece of paper and you're going to start off by putting it on the major axis line, something like that there, and where the point of the ellipse is, right at the end of the major axis, I'm going to mark that right there. Okay, right there on my paper. And I'm going to call that P. Okay, right there. What I'm also going to mark on it from P is I'm going to mark to the center of the major axis, which is right there. And I'm going to mark that MAJ. Okay, MAJ, or if you wanted, you could call it A. Okay, so the distance from P to the center of the major axis. That is the first one I'm going to mark. The next one I'm going to mark, and what I'm going to do is I'm going to put P, because remember P is a point once again on the ellipse. I'm going to mark it this time from the top of the minor axis, which is up here. Okay, and from where P is on the minor, make sure it's exactly on it. I'm going to once again mark into the center, only this time I'm marking to the center of the minor axis. I'm going to mark it right there. Make sure you're 100% accurate with it. Okay, just about there. Yeah, happy with that. And with that then, what I'm going to do is I'm going to write in minor. Or in this case, M-I-N, which is for minor. Or if you wanted to just use a letter, you could use B. Okay? And what that means is, it's going to help us draw basically a portion of our ellipse. So at this point now, if you wanted, just to show you there, you could take your set square and just cut off the excess. And what we have is our Trammel set up. Okay, for the P at the start, I would always mark it in a little bit from the end, okay, of the piece of paper. I wouldn't usually keep it at the end. Okay, I mark it in a little bit. Now, the method for actually drawing in the ellipse using the Trammel method is quite a simple one. What we're going to do is we're going to plot points that are on the elliptical curve, okay, by using both the minor and the major. Okay, so to find a point on the curve, okay, there's a little bit of kind of technique in this, but what you do is the major axis point, okay, which is A, I'm going to keep that going along the minor axis line, which is going up and down like this. So A always has to stay on it, okay, and likewise with the minor axis point, that always has to stay on the major axis. Okay, so if I mark it here, I'll actually do it a little bit closer. So I'm going to work down this length, okay, to get this portion up here. So the major axis point is along the minor axis line. Okay, the minor axis point is along the major axis line, and that there gives me a point on the curve right here. So I'd mark that there. Okay, now you can see I found a point here. Okay, so what I want to do is I want to find a series of points all the way along it. So to find another one, I'm going to move it further down, kind of find about maybe 3, probably should help me. So about there, happy with that. The major axis is along the minor axis line. Okay, the major axis point, I should say, is along the minor axis line, and the minor axis point is along the major axis line. That there gives me another one. Okay, and then finally you can see here I found 2 of them. I'm going to find one more up about here, so I'll go further down. So major axis point, a little bit maybe about here. Quite happy with that. So right there and there, you can see I'm lined up with it, and I found another point. Okay, and now what I'm going to do is I'm going to continue it on the opposite side. So I found 3 points there. Okay, so same thing, make sure it's on it here. Happy with that. I'll rotate it until it's in position. So I'm quite happy with that there. That gives me another point right here, and going to do the same. And you can see here it's just going to keep working its way around. It's just a little bit of practice and technique in it. That'll give me another point over here. Probably went a little bit far there, so I'm going to try and find one in the middle now. So there's another one. Okay, and as you can see there, I found a series of points. Now I can actually plot my curve. So I'll sketch that in there now quickly, so I'll speed up the video. Okay, Okay, so there we have it. That is the top portion of our ellipse. Now what we have to do is we have to find the bottom portion. Okay, so applying the same method, okay, like we did here where the major axis was on the minor, we just do the same, only going upside down. So I'm going to keep the major axis point along the minor axis line and the minor axis point along the major axis line. Okay, so just finding them there. Move down, actually I would project. Start by finding one that's close enough to it. So about here, I'm happy with that. That gives me a point on the curve there. Then I'll move it up a little bit and down a little bit. So major axis point is on the minor axis. The minor axis point is on the major axis. There gives me another point. Another point. I'll keep moving this. Another point. And finally, there's one more. You can see the path of the points. Okay. And going to do the same then going in this direction. There's another point. Point. Keep continuing on with this process where the major axis is on the major axis point is on the minor axis line and the minor axis point is on the major point. And then finally the last one that I think I'll need about there. I'm happy with that. Yep. Okay. And once again, quickly going to sketching that, so I'll speed up the video. Right folks, so there you have it. That there is how you construct an ellipse using the Trammel method. Okay, always you're just going to need a piece of paper, and at the very start what you're going to do is you're going to note a point, okay, that's on the curve, so either end of the major axis, okay, is to start off with, and from that point there to the center of the major axis gives you point A, and then what you can do is rotate the point until it's at the either end of the minor axis to locate from there to the center, which will give us point P. And then we literally make sure that A and B are along the major and minor, and we can plot our curves around. And as you can see there, it kind of follows that path there. Okay? And it continues the whole way around. So that there, guys, is using the Trammel method there to construct an ellipse. Okay.